Good day, welcome to Great White Retro. I'm Gord Fessick, and this is the LittleSixteen project by sukkopera. This is revision 4, and it's also release candidate 16, which he has graciously allowed me to try out. This is a modern recreation of the Commodore Plus 4 and Commodore 16 machines from 1984. It uses almost all off-the-shelf parts. You still need an original processor and TED chip. We're going to work on getting the Commodore 16 portion of it working first, and then in subsequent episodes we'll get the user port working, and then we'll get some of the neat new features working. Let's get her done. To build this project, we're going to need some specialized tools. Need a half-decent soldering iron, multimeter for checking connections. You'll need an EPROM programmer to be able to program the ROMs and the GAL devices that you're going to be ordering. And to help tune the video and the clock crystal, a scope is recommended, but I will see if we can get away without needing the scope, although I'm probably going to use it. Some side cutters for cutting the wires. And if you're going to attempt the surface mount components on here, some solder paste. It'll be a lot easier than trying to use the solder spool for a surface mount. We're also going to make use of some tools that sukkopera provided. He provides an interactive bill of materials. When you do a project in KiCad, you can save the board layout and a list of all the materials you're going to need. The interactive bill of materials will actually show where everything goes. And you can also check off components as you install them. For instance, as we install these capacitors, it'll highlight where you put them on the board, just like that. We're also going to want to read, how do you want to start the configuration? Do you want to use the surface mount stuff? Do you not want to use it? You want to plan out how you're going to do this. And this configuration guide will help you get that started. The assembly notes guide suggests that if you want to install the real electrostatic discharge filters, we should put these on first. The thing is, these are very, very small parts. I mean, I can't even tell where pin 1 is on here. In fact, I'm already losing them. Okay, you know what? I'm going to give this up and I'm going to stick with the old style because I do not trust what I've done here. Nope, 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 nope. Sorry. We'll just have to stick to the original Commodore solution of adding diodes elsewhere. So if we're not going to put those diodes on, we're going to skip ahead with putting on the power components next. Okay, so we're going to use a standard 8501, well, standard for Commodore. We'll burn an EPROM later on with this layout. We'll prepare these PLAs later on. We'll do the cheap, easy method for the video first. If that doesn't work out, we'll install variable resistors in these two spots. We do have new bricks, so we'll be able to use a modern 64 power supply, and we'll worry about the sound chip later. So, first things first, we'll add the power components and we'll make sure we're getting good power. Alright, power connector. Now that we've got the right pin out here, we'll set this in place. This is going to make soldering the other components rather difficult, but I'll manage. So we'll get one pin in first. We'll line it up. And we'll get the others. Sukkopera's assembly notes say to install the power components first, and that is so you can test your power supply to make sure it works. A lot of the old C64 power supplies have the potential to overvoltage your board, damaging components. My problem with this is this leaves some very high-profile components on the top right corner of the board, which will make installing things like sockets, filter capacitors, resistors, ferrite beads that much more difficult because they won't be able to sit flat when you hold the board upside down to install these. I also have a personal problem with that because
I get confused really quickly, and I like to install the same component in batches. Like, I'd install all the sockets first, then I'd install all of the filter caps first, then all the ferrite beads, then all the resistors of the same value, then all the diodes, and so on, so I don't lose track of my parts. I would say do it how you want to do it, but leave that line filter there. It's labeled LF100. Leave that for last. That's the part that goes right behind the power connector. That way you can test your power supply without exposing it to the rest of your board, so you don't risk damaging your components. Once you know your power supply is good, then you can install LF100. Also, there was this bleeder resistor here. That thing gave me problems when I was trying to look for short circuits on the board.
Okay, I'm supposed to do the ground on the rightmost side as well. Okay, there, okay. Alright, so I'm getting 5.2, which is correct for this power supply. So between the plus and minus AC, I'm getting 10.97. There we go. That's better. And I'm getting 5.2, which is what I typically get on a new brick. The power supply is good. Now I can install our line filters.
Next in Sukkopera's assembly notes was to put together the clock circuit. Turns out that my scope wasn't high enough resolution to do a 14 megahertz or a 17 megahertz signal, so it really didn't matter for me, but I was just following the notes at least to start. And as you can see, I've got several bags of components up there in the corner, and I am just fishing out bits and bobs. If I were smarter, I would have pre-organized all of these beforehand and set out the parts that I wanted. But again, I'm not being so smart here. I think I would just do all the components of the same type and same value, just like I talked about earlier. But still, when you get to the clock circuit part, you can still do the tests for that, because if you don't have a TED chip installed, the clock circuit will be isolated from the rest of the board. Now with the power and clock circuits completed, we can do the whole rest of the board. Now, his assembly notes say not to put anything into the user port or SID sections of the board, but once again, I've got all these parts and I might as well put them all in here. As long as I don't have ICs inserted in those sections, they're going to be isolated from the rest of the board. Let's start with all of the filter caps. And one thing you may have noticed is that in the clock circuit section, I have this 6-pin socket. That is so I can quickly change the clock IC between NTSC and PAL. If you pull a stunt like this, make sure you cut the leads on the clock crystals as short as you can get away with, so that you're not introducing additional capacitance to the circuit, because every little bit will impact the clock circuit, as I found out when I was trying to tune the video.
Those are the filter caps, so I want to make sure that there's no shorts between ground and 5 volts after doing that. And all I gotta do is go between ground and 5 volts on something handy like, ooh, that's not good. Yeah, we've got a dead short somewhere. Well, that didn't take long.
Remember that bleeder resistor? Yeah, that thing. That's designed to drain the capacitors of charge once power's been removed from the board. The problem is, while you're trying to check the board for shorts, that is a 10 ohm almost short circuit across the entire 5 volt plane. While I aborted this board and did the assembly on another board, I came back to this and I would remove this resistor for testing, and then I would put it back when I was done. It's important to keep on there, but while you're assembling the board and checking for shorts, leave that one for second to last. So continuing just on my own here, I started installing the next batch of large amounts of components, which was these diodes. These are used for electrostatic discharge protection. This was a workaround that Commodore did on the original Plus 4 and C16. The surface mount diodes are a better option, but I just didn't have the skills for that. I just went and installed all of these diodes. Next came the ferrite beads. These are used for electromagnetic interference protection. They're on almost every input-output pin on the board, just like the original C16 and Plus 4 had. But there was a bit of confusion on the ones for the video output. There were a special 3-pin version that also had a connection to ground, and that helped reduce the EM interference even further. Since I only had 3 of those, I decided to put them on the video ports, the composite Luma and Chroma pins. But I suppose ideally you want to put these on almost every ferrite bead. Here they are right there. So you can use either kind on all the places where there's a ferrite bead. But I guess for cost, you can use regular ferrite beads everywhere else. I would just recommend using these 3 for the video.
So this was that power connector I was fighting with earlier. The original connector has these 2 pins a little further up than they were supposed to. They also have this extra pin in the back. This bottom piece, like this shield comes off, and this bottom piece comes off. So I can remove one of these pins. But I also have to move these 2 pins back into a couple of the smaller holes that are here. But this shield will not quite fit because there's a metal frame that gets in the way of the mounting plastic. I had to Dremel myself a little trench inside this bottom piece here. So the end result looks like this. And now the connector fits. Sometimes you have to use the unusual tools.
Now comes all the rest of the low-profile components, including several resistors. These are self-resetting fuses. They're on every I/O pin that supports plus 5 volts or AC output. These will self-reset in case of a short circuit, so it's like a fuse that you don't have to replace. Commodore used these on the original machines, and Sukkopera is following suit here. They are listed as R or resistor parts, but they are not really resistor parts. These are self-resetting fuses. Next come my first electrolytic capacitors, aside from the one for power. The wrap that holds these leads in place is so tight that I just had to cut the leads off of it. Just remember that the negative part of the cap goes onto the white part of the silk screen, and you should be fine, just like that. Also, skip this cap here, skip C110 until the socket for the RS-232 UART is installed. That's U21. Otherwise you're going to have a hard time installing the socket and surrounding components.
At 12 noon on a Sunday, I have gotten this far. I have ordered some of the components that I missed the first time. And when I come back from lunch, I'll start putting on jumpers, pin headers, resistor packs, sockets. These resistor packs are going to be a problem because the power supply instructions required me to mount the taller components really early on in the build. So I've got some painter's tape here to help me hold them in place. With any luck, that'll be enough.
So for all of these lower profile components, I would hold it in place with some tape. I would solder 1 or 2 pins, and then I would apply some pressure from underneath while pressing up, then loosening that 1 pin until the whole component was flat in place. Only then would I solder the remaining pins. This is what all the resistor packs look like. Skipping ahead to the sockets, we're going to make 2 decisions here. We're going to replace the MOS parallel I/O controller parts with generic parts. This is where we're going to use a 74LS273 part for the keyboard. This is going to cause the keyboard test in Diag 264 to fail, but that's okay because we can still do individual key tests here. This silk screen clearly labels where you're supposed to put the socket based on what part you're going to use. So we're going to put the socket in the upper part here. We're going to solder 1 pin on each corner just like we did before. We're going to use some flux paste here to help out with actual soldering, and then we will actually do all the pins. This flux paste does make the process go a lot faster because it'll help remove any oxidation on the pins and on the solder pads. And then we'll be able to do the soldering of these pins very quickly. Likewise, we're going to use a substitute part here on the user port. Now there is actually a design out there to replace the 6529 part with a 74LS654 part. Now that part is also obsolete, but can still be made today. Rochester Electronics manufactures obsolete parts for this sort of purpose. Skipping even further ahead, we are down to the last socket, U1, the TED chip. While we're putting this chip in there, Sukkopera has asked me to speak up about this board. The big thing is, this is the version 4 of the LittleSixteen, and it hasn't quite yet been released as of April. Version 2 was originally a 1-to-1 copy of the Commodore 16. Version 3 introduced a lot of improvements, including using the standard joystick ports and so forth. This version here is aiming to be a complete +4 compatible. We've got the user port, we've got the SID chip, we've got expansion RAM up to 512K. This is an open source project, meaning that you can contribute to the design of this board. The schematics in KiCad are available, and you can build your own Gerber files from that. KiCad is also a free project. He also wanted me to clear up some things about the use of a Western Design Center 6502 part. While it can be used with an adapter for the 8501 to the 6502, the older parts supported some unsupported or so-called illegal processor opcodes that the modern part does not support. There's no guarantee that the older software will run with the WDC part, although I aim to find out in a future episode. I am very curious to see if we can use a modern 6502 part on here. For some reason, the connector that I got for CN6 was identical to the power connector. In fact, even the power connectors were identical to the CN6 connector. I don't know what happened there. The big difference is that the two top pins are directly vertical above the two outer edge pins, whereas on the power connector, this whole connector is slightly rounded, and there's this extra pin right above the middle pin. This is a spare connector that I got when I was doing my VIC-20 S-Video conversion. I'm going to have to get more of these now, and I've only got one, so I'm only ever going to get this build finished, at least for now. Strangely, this one has 5 volts output on it. That's something I've only ever seen on the VIC-20 before. I checked one more time across the 5 volt and ground pins, and the only short we had was from the bleed resistor. One of the big improvements here is the use of standard joystick ports and those two IC sockets that act as buffers to protect the TED chip from the joystick ports. These require a big old blob of solder on the structural bits here so that those joystick ports do not come apart. There are also jumpers on the board to enable or disable +5 volts on those ports, so you don't need to be providing power to those unless you want to use an auto-fire joystick or something. If you do that, just make sure that this thing is compatible with a C64. Some of the auto-fire joysticks will draw too much power and could potentially fry those buffer ICs. After giving this a good scrub with 99% IPA and a soft bristle toothbrush, I inspected this board for solder bridges, splotches, other various mistakes. I spent a significant amount of time scraping away solder that had splotched off to one side or another. I just looked carefully and I removed loose bits that I could see, and I eventually got it to the point where I was comfortable inserting all of the ICs to power this thing on. Next came all of the programmable ICs. I did U3 and U4 with the PAL versions of the firmware, BASIC, and Diag 264. I was planning on switching back and forth between the standard firmware and the Diag 264 firmware for testing, and I would eventually add Jiffy DOS, and yes, I paid for Jiffy DOS. So this is XEGCU. You can certainly use Mini Pro or your favorite EPROM programming software for this purpose. And I will link to an EPROM assembly helper that you can use in PowerShell to help you put together these EPROM images. The order of these images matter, and sukkopera's assembly guide describes what order you need to put the EPROMs in on these. And these are 512 EPROMs, so they are 64K each. And there's a jumper that'll let you switch between U3 or U4. Next comes the two GAL devices. These are still manufactured today, and you can still program them using the XEGCU programmer, just like I'm doing here. U19, U26, and U28 are programmable. And I have my IC straightener there that I just picked up from an eBay vendor. It helps a lot with these double wipe sockets. Let's get the remaining ICs in here. We'll start with the crystal. This is the PAL crystal, and I've got those leads as short as I can get away with. I'm putting a grounding strap on there for the back socket there so that the can of this crystal is grounded. And we'll cut that there. Next, let's get the RAM in there. This is 512 kilobytes of RAM, more RAM than a Plus 4 has ever had before, and it's actually supported. Next, let's get the ROM switcher IC, followed by the keyboard buffers, more logic, even more logic. We'll get the 555 timer in there. That's responsible for resetting the CPU on power up. These are the joystick buffers, more logic, registers, flip-flops, more logic, even more logic. Here's the main CPU. This is an 8501. And here's the star of the show, the TED chip. We don't have modern equivalents of this really, but we're getting there.
I am totally not expecting this to work on the first try. I can hope, but let's be honest. There could be any number of things wrong with this build, like me getting my wrist strap tangled up in here, for instance. First, we turn on the new brick. Okay, no smoke. That's a good sign. And drum roll, please. We are apparently running the Diag 264, and it's running. It's in black and white, but it's running. Yeah, it's in PAL. It found the ROMs. It's not going to pass the keyboard because I don't have any of my keyboard testing tools hooked up. I'm kind of surprised. Yeah, keyboard bad, I know that. But it works. It runs. We have sound. Holy moly. Okay, well, that was neat. This is what I am actually getting right now. This is completely unexpected. So right now I've got no color, and I have no composite video either. I don't know why I don't have those yet. I'll check on those pins in a bit, but this is already more than I ever could have expected on the first boot up. I'm gonna go get the diagnostic harness and give it a run, but I'm going to have to prepare the Atari style joystick cables yet, because I don't have those yet. This is as much a test of my modified test harness as it is of this board. We know the board at least boots to basic. Let's see what we get. Okay, we're not in diag mode, so let's try again. Okay, that's in diag mode. It's in black and white still because I haven't figured out why we got no chroma signal. These joystick ports actually have a ground pin, not a select pin. I am hoping that this can actually distinguish between the two. We'll see in a moment. It's possible the joystick ports are not going to behave as expected. It thinks the keyboard is bad, but it thinks the joysticks are okay. Interesting. And it thinks the cassette port is bad too, but I think that's understood right now. It also thinks the cassette port is bad, but the installation guide tells me that initially the cassette port won't be working right. There's some things we have to do yet. It still thinks that the 6529 is bad on the keyboard, but we're not using a 6529, so that might be the reason. Okay, so shift lock so it bypasses those tests. Keyboard skip, joystick skip. Alright, that's expected. Escape. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So far they're working. It seems to think all the keys are working. That is interesting. It said that the 6529 was bad, but we're not using a 6529. A Diag 264 must be using something else.
There's a lot of troubleshooting that went on after this, and you already saw the results of that on shorts that were published only a few days ago. We did get this thing working, and we got it working in color, even in NTSC. We will go through the troubleshooting process for that in a future episode. Until then, good day.